Hello and welcome to an overview about our exciting new certificate program, Green Chemistry for Climate and Sustainability. Our goal for this presentation is to give you an idea of course content and format for this 9-month program. This is an innovative new initiative through the School of the Environment and the Center for Green Chemistry and Green Engineering at Yale University. Throughout the program, you will learn from the lead faculty at Yale University, Dr. Julie Zimmerman, Dr. Paula Anastas, and myself, Dr. Margaret Kerr. In addition to the lead faculty, we have many experts in the field from around the world providing an exciting curriculum through asynchronous video content and through weekly synchronous sessions where you will be able to interact and ask questions. What can you expect from this program? This program is fully online and is designed to accommodate people who work. Only a single session per week is synchronous. Everything else can be done at your convenience. Networking opportunities are available with experts each week, in addition to the other learners in the program during group activities and discussion sections. You will receive expert guidance on assignments and mentoring throughout the program. We will work with you to develop leadership skills that will allow you to bring green chemistry and green engineering practices to your workplace. We have developed an ongoing capstone project that is designed to encourage you to think holistically and to develop a practical proposal for implementation of a greener process or product once you have completed the program. We are planning a hybrid conference at Yale University at the end of the program to create additional opportunities for networking and implementation planning. Overall, we will create a framework to positively influence decisions related to broader innovation practices in safer chemical and process design.
Hi, I'm Paul Anastas. I'm a professor here at Yale University, and I teach green chemistry. And one of the questions you're probably asking is this certificate program for me? We have geared this so that if you're a professional who's interested in how do you use chemistry, chemical engineering in advancing the goals of sustainability and innovation, this certificate program is for you. If you're a student or young professional that's just starting out and you want to know how to utilize green chemistry and green engineering to advance the addressing of climate change and sustainability, this program is for you. If you are involved in the broad chemical enterprise, yes, the chemical industry, but far beyond, policy, communication, investment, business, not-for-profit, is this certificate program for you? Yes, it is. So this is the broadest definition of all of the different aspects of what green chemistry touches, what green chemistry addresses, and so the answer is we have designed this certificate program to be broadly applicable. So years ago, people would ask, why do green chemistry? It's not my job. It's not in my job description. Well, I'd ask you to imagine a chef that said, oh, I make meals that are delicious. Sure, they're poisonous and kill people, but there are other people working on non-lethal cooking. Or imagine the architect who says, the homes and buildings that I make are luxurious and attractive. Yes, they collapse unexpectedly and harm people and kill people, but there are other people who work on safe housing. Or the car designer who makes powerful, fast, beautiful cars, but they fall apart and explode unexpectedly. But there are other people who work on sustainable cars. Now, imagine the chemist. I've worked on making large numbers of molecules, large numbers of chemicals and materials and synthetic methodologies. Yes, they harm human health and the environment, but there are other people working on green chemistry. For the same reason the first three examples are absurd, this last one is absurd. And so green chemistry is an essential part of all of us who are designed in the material basis of our society and our economy.
We have lots of lessons about pursuing things like green chemistry, sustainability, mitigating climate change, and these are really important and noble goals. They're the right things to be doing, but sometimes we wind up doing the right things in the wrong way. This picture is of a tanker car going past the Capitol building in Washington, D.C. These kinds of tanker cars happen in cities and urban centers all over the world. That tanker car is carrying chlorine, and it is heading, in this case, to the Blue Plains drinking water treatment plant to disinfect drinking water for the people who live in Washington, D.C. Of course, we have to supply safe drinking water for people in the cities, but if anybody steps back and thinks, what was chlorine gas originally patented for? It was actually patented in the early 1900s during World War I as a chemical warfare agent. We are taking something we know is incredibly harmful and toxic, putting it in tanker cars and driving it through our city centers. This exposes us and makes us vulnerable to accidents or terrorism. And we know that when we use these chemicals like chlorine to treat our drinking water, we produce something called disinfection byproducts. These are known human carcinogens. So, do we need to provide safe, clean drinking water? Yes. Is this the most sustainable way to do that? Probably not. And so we are doing the right thing, but in the wrong way. We can look at other examples of where we have the right goal and the right noble goal that we're pursuing, but is the chemistry, is the production, are the policies that are enabling it the right ones?
The example of making renewable biofuels, but using corn sugar to do it. Corn sugars that compete with food, feed, land use options, use tremendous amounts of water, contaminate tremendous amounts of water all the way to the Gulf of Mexico here in the United States. So yes, we want to have renewable fuels, but we don't want to do it in the wrong way.
The chemical enterprise is a major economic contributor. If you look over the past several decades at the growth of the chemical industry, you'll see the gross domestic product is about $6 trillion US. If the chemical enterprise was a country, it would be third in the world in gross domestic product. The chemical enterprise has a huge footprint in terms of economic activity and driving economic activity. And it gives us a tremendous leverage point because if we can figure out how to address the impact of the chemical enterprise through green chemistry, we can make massive change at scale.
We also know that all of this economic advance has historically, and sadly still today, come at quite a cost. One example of a fairly recent freight train accident that released vinyl chloride, hydrochloric acid, and phosgene is just one of the many historical tragedies that we've seen from unsustainable products, processes, feedstocks, and supply chains. This type of accident causes widespread contamination, this one in particular cutting across 16 states.
So, how should green chemistry be done? How do we keep winding up doing the right things wrong? If we step back and we look at today's chemical sector, we'll see it's quite linear. We take things out of the earth, often fossil fuels, petroleum resources. We produce goods and products, people use them, and then at end of life, they often wind up in a landfill or they're incinerated. And we know what the fate and transport of these molecules are once they're out in the environment and the harm they cause to human health. If we look at what the future of the chemical enterprise would look like, if we pursue green chemistry, if we do the right things in the right way, if we start thinking about sustainability and mitigating climate change, we would see that tomorrow's chemical sector looks much more circular. That we start from renewable feedstocks, things that we can grow in ways that are sustainable or using agricultural wastes. And we start to see that production and the use phase give back in terms of reusing and recycling so that waste becomes a feedstock for the next generation of products. We eliminate distributing toxic molecules out into the environment that we know, again, are harmful to ecosystems and human health. We need to think in systems about what we're doing in the chemical enterprise to avoid the unintended consequences in doing the right things wrong.
So there's a framework for how we move from this old way of doing things, not only what we make, but how we make it, into a future framework where we not only get all of the function and performance that we want, but we do it in a way that is going to be conducive to life and support human health, the health of our biosphere. So we'll be covering in this certificate program this thinking, those frameworks for how we go about doing it. So it's not just theory, but we're going to cover a lot of how you turn theory into practice, how you turn innovation into impact. So, as many of you know, there are the 12 principles of green chemistry that have been around for quite some time. This framework cuts across the entirety of the life cycle and makes sure that we use the chemistry of sustainability, green chemistry, in ways that are going to align our environmental and human health goals with our economic and profitability goals. These 12 principles do form the basis of our thinking. They act as a guidepost, a recipe that we use as we talk through these great grand challenges.
The field of green chemistry has grown over the past 25 years, and if we think about the analogy of a tree, we can go and look at the roots of when this definition of the field of green chemistry emerged and the principles came out, and then see what has grown and what has borne fruit over the past 20 years. And we see that on every branch of that tree, there are leaves that represent new technologies, new processes, new molecules, new ways of moving the chemical enterprise from that linear model to one that is more circular and sustainable. If we look closely at these leaves, we see and get hints about how do we use carbon dioxide as a renewable feedstock? How do we do transformations, again, using sunlight the way nature does, rather than using lots of energy and reactive chemistry? Green chemistry in the past 25 years has had incredible accomplishments, and it is out in the public domain. We are seeing headlines across many different newspapers and magazines around the world that talk about the power and potential of green chemistry, not only to make the world more sustainable and to help address climate change, but to also make money and see rewards for the people who are investing and pursuing this approach. We see networks that have emerged, again, all over the world, from Africa to South America to Asia, and of course in Europe and North America, of researchers coming together with investors, with policymakers, to support and enable this transition from a linear chemical enterprise to one that is more circular and sustainable. There are conferences that happen, again, all over the world to bring together people who are engaged in green chemistry and interested in seeing this transition so that we can work together to make these changes. Research is happening on topics and in places and universities and small businesses all over the world. We also see the adoption of green chemistry by large companies who are interested in making this change.
The international engagement is an important part of this, and it's an important part of the network that you will be joining as you engage in this certificate program. There were well over 40 countries with well-developed networks and international organizations, certainly the United Nations and the OECD, but also the Pan-African Green Chemistry Network, the Asia-Oceanic Network, and well beyond. So when we take a look at this program and how it's structured, we have this periodic table metaphor, this metaphoric periodic table that was generated a few years ago. And as you can see from its colors, it's somewhat of a tribute to the Sustainable Development Goals. So how does green chemistry address those great grand challenges of the Sustainable Development Goals? Well, we structure this by looking at why we do what we do. The middle elements are, what is the essence of the science and technology? What happens in the labs and in the companies? But it's also looking at How do we turn those discoveries and inventions and innovations into impact? How do we do it so that we're going to go to scale at the time frame and the urgency that's necessary in order to influence people's lives in the time frame that's necessary? And then, of course, on the far right are the noble goals, those over the horizon, those visions of the future that we want to always strive for, even when we know we're pursuing perfection. So yes, that's why we do it. This is the tools that we use to do it. These are the ways that we go about bringing them to scale, and yes, we have the noble goals.
So the first course of this certificate is the essence of green chemistry. Why do we do it? It starts with a very basic question. What is the role of green chemistry in sustainability? Sustainable development is defined by the Brundtland Commission in 1987 about meeting the needs of the present without compromising the ability of future generations to meet their own needs. This aligns very well with the field of green chemistry. This idea of making things, providing goods and services, improving quality of life without causing harm to human health and the environment. We want to preserve what you can't live without and preserve it forever, as Paul Anestis says.
One of the great sayings that I often cherish is that we do not inherit the earth from our ancestors, but we borrow it from our children. So these Sustainable Development Goals, and many of you are quite familiar with, they're iconic. They touch all aspects of our world and our society. And I have to say, while many people think that green chemistry will touch 2, 3, 4, I happen to be a believer that green chemistry has a way of enabling meeting all 17 of these goals. And we'll address that in this certificate program. So green chemistry should be viewed as an integral component to all aspects of the Sustainable Development Goals, whether it's how we go about fighting climate change by how we generate, store, and transport our energy, whether it's how we go about combating climate change and pursuing sustainable development and how we make things and what we make, how we grow our food and provide nutrition and preserve health, or how we get around, either as people or shipping our goods from one place to another, and the fuels and energy that's necessary to do that.
Embedded in all of this, of course, is the role of equity and environmental justice. We know that linear chemical enterprise, with all its unintended consequences, results in communities that are disproportionately disadvantaged by the toxic, wasteful chemical sector that we currently have today. Green chemistry thinks about changing what's happening in those factories so that the fence line communities that live near them aren't disproportionately burdened with emissions that are coming out of those plants or vulnerable to accidents that happen within them. You can go further down and think about the way that green chemistry helps to address environmental injustices that are happening. Everything from what is the value of the real estate of that home that is on a fence line of a chemical plant, or the workers that are working in that plant and how safe they are from the chemicals that they're handling. If we change what's happening, the inherent nature of the chemicals and materials that we're using and we're producing, we address not just the obvious harms that are causing environmental injustice, but deeper issues of intergenerational wealth and learning opportunities and tax base for these communities. What if we change the chemical enterprise so it went from not in my backyard, don't build that chemical plant here, to please bring your green chemistry, bring your sustainable and circular chemistry and production to my community, because it is money and investment and job creation, and I don't have to trade off my health or well-being or the environment around me for the benefit of having economic activity in my community.
So this cascade, this way of changing from depleting to renewable, from toxic to healthful, from degrading to restorative, is not just about a manufacturing process or a particular chemical product. This is about how it affects individuals, how it affects communities, and how it affects generations.
So, Course 2 will talk about the tools and how to enable green chemistry in practice. What does this look like? This will talk about the circular economy and when is a waste not a waste. When do we produce things and produce waste, but we have designed the process so those wastes are useful in other industrial processes. A great example of this is the idea, again, of using this tree metaphor and saying, if we start from carbon dioxide at the roots, what are all the different chemical and materials that we can produce? And so how do we take our greatest problem when it comes to climate change and the biggest source of waste in the world, carbon dioxide, and turn it into a value-added feedstock? Again, if we zoom in and we look at this tree, we can see that carbon dioxide can be made into fuels and chemicals and materials and building blocks for more complicated products. And we're starting from something that is inherently wasteful and now giving it economic value and making it part of the solution. We can also think about when we grow feedstocks, when we find things in the field or the forest, and make it analogous to how we do petroleum and that system. And so when you drill up a barrel of crude oil, every fraction of that barrel gets used for some value-added product. Whether it's kerosene or gasoline or jet fuel or naphtha, there is an economic value to every fraction of that barrel of crude oil. And we need to build the analogous system for the bioeconomy. How do you take every fraction of a tree or agricultural waste or algae and find economic value in it? That is the only way we're going to be able to compete and transition, because a biorefinery doesn't produce waste that doesn't have economic value. Like the petroleum system, we'll find economic value in all of it, and we'll start from something that is safe and sustainable by design. There's been a lot of research to show that we can start from a variety of renewable feedstocks and find starch or carbohydrates or oils or protein, and chemistry has already been done and demonstrated to convert these starting molecules into things that are useful and value added and are already part of today's chemical enterprise. So this is an opportunity for just drop-in replacement of petroleum feedstocks with renewable feedstocks to make the same goods and services we're used to today. The third course of this certificate is about green chemistry, accelerating and implementing for impact. This starts to ask questions about how policy is part of our solution. Whether we think about how to protect human health more effectively, what is the nature of the kinds of chemicals and harms that we're causing, and how do we write policy to not only limit people's exposure, whether that's wearing a respirator or a mask or a lab coat or putting scrubbers on smokestacks. This is about how do we start to encourage the design of safe chemicals by policy that protects human health. We can also have policies around protecting environmental health and what does it mean to have chemicals that are out in the environment that are persistent and bioaccumulate in our food chains, and changing the inherent nature of our chemicals and materials through policies that are intended to protect ecosystem function. And we can use policy to drive innovation and encourage the production of more safe and sustainable chemistry. So this is everything from tax credits to research and development, incentives, to extending patent life for technologies that align with the principles of green chemistry. Do we have the tools to make this transition? Do we really have this knowledge? We do. There are so many examples of all of this research that has been published. And excitingly, this book recently published by researchers at the Yale Center for Green Chemistry and Green Engineering, Paul Anastas and Predrag Petrovic, that came out called First Do No Harm, borrowing the Hippocratic Oath from the medical sector and saying, how do we as chemists first do no harm? How do we change? What are the molecules that we're making, and what policies would support advancing that? We can design, and we know how to do this, products so that they're degradable at end of life and so that they don't persist out in the environment. And most importantly, that when they do degrade, they degrade into things that are safe and benign for human health and the environment. Our best example about how to design things that are degradable is to learn how nature does it, to look to something called biomimicry. So if you think about a shrimp shell or a crab shell, that's a polymer. It's a plastic, just like our soda bottles or water bottles might be. But when those animals die, that shell degrades into something that is benign and safe and can be uptaken and used by other organisms in the ecosystem. We see lots of examples from biomimicry about different functions, whether it's cleaning water or sequestering carbon dioxide, or in this case of the example of a gecko, of providing adhesion. So if you think about our adhesives today and the life cycle, starting from petroleum-based feedstocks and reactive chemistries that happen to make something sticky, and then we look at nature and we say, how does that gecko climb up the wall and stick on the ceiling? Not only that, it takes its foot off and puts its foot back on without losing any of the adhesive function. What is the life cycle of that? And you zoom in on the bottom of a gecko foot, you'll see lots, billions in fact, of keratin fibers made out of proteins that all together provide enough charge on the bottom of that foot to interact with the charge on the wall. And through really weak forces called van der Waals interactions, that gecko foot sticks to that wall, but not so much that it can't take its foot off and put it back on. We get all the service and function of adhesion, of something sticky, without a molecule that is adhesive, that has a life cycle associated with it. So we can learn how nature does things by looking at how nature has already solved some of our challenges, whether it's reducing friction as we move through liquid or through air, and designing our industrial products to mimic those forms and shapes that nature has already told us are aerodynamic and use the least amount of energy for transportation.
And then, of course, the noble goals, ensuring that we never settle for what we can do today and tomorrow, but we constantly aspire in the years and generations to come toward noble goals. So this is the great grand challenge of our generation, and I so hope that you see this certificate program as a part of your journey, a part of adding to your capabilities, a part of enabling your impact. Because when we step back and look at who is going to provide the leadership for the future science and technology and ensuring that science and technology advances sustainability and combats climate change, who will provide the leadership? You. And how do you want to proceed? With brilliance and optimism. When you bring the capabilities to bear on these great grand challenges, proceed responsibly with humility and courage. You have to have that conviction and that commitment, and what we're committed to is to providing you with the perspective, the tools, the skills, the knowledge, and the capabilities of pursuing those great, grand, noble goals. We will because we can, and we will because we must. Change is crucial to the path forward. It's crucial to the goals that we all share. And I so very much hope that this certificate program will give you what you need and that you will be part of it and join us. So what about you? What will you want to invent? Will it be a new policy? Will it be a new business model? Will it be a new molecule? Will it be a new collaboration? How can you use green chemistry and green engineering to advance the goals of your community, the goals of your company, the goals of your sector, the goals of your ministry or agency? What role do you want to have in the future? And how can this certificate program be a part of enabling you to meet those goals? So the future of green chemistry and green engineering is in your hand. Most importantly, the future of this society, our world, is in your hands. And all we want the certificate program to do is help you achieve those goals. Thanks so much. And please, for more information, just come to our website, get in contact with us. There's nothing we would like more than to engage with you and bring you in to this initiative. Thanks so much.